In continuation with the topic cement, we go for the next point, that is box compound. The raw material used for the manufacturing of the cement is when subjected to the high temperature. Then the material combines with each other and the complex compounds are formed, which are known as the box compound. The During manufacturing of the cement, the raw material are combines with each other and they form the compounds which are known as the box compounds. The table shows the box compound, their chemical composition and the abbreviation, that is, first is tricalcium silicate C3S, dicalcium silicate C2S, tricalcium aluminate C3A and tetracalcium aluminum ferrite C4AF. So these are the both compounds which are formed during manufacturing of the cement. Next is properties of the box compound. First is C3S, that is tricalcium silicate. It is responsible for the early strength. First 7-day strength is due to the C3S. It produces more heat of hydration. A cement with more C3S content is better for cold weather concreting. So the tricalcium silicate is responsible for the early strength of the concrete. So in 7 days, the strength is due to the tricalcium silicate. In cold weather condition where the temperature is less than 4 degree and we require to set the concrete or required early strength to the concrete, due to the low temperature, the heat of hydration decreases and also it affects on the rate of gaining of the strength. That is, it decreases the rate of gaining strength of the cement or the concrete. So to increase the heat of hydration in cold weather condition, we use the cement with more amount of tricalcium silicate. Next is dicalcium silicate. The hydration of dicalcium silicate start after 7 days, hence it gives strength after 7 days. Dicalcium silicate hydrate and hardens slowly, so it provides ultimate strength. It is responsible for the lateral strength of the concrete and it produces less heat of hydration. So the hydration of the dicalcium silicate is start after 7 days. So it is responsible to give a strength to the cement or the concrete after 7 days. It having the less heat of hydration or it produces the less heat of hydration. So where we require the cement with a low heat of hydration, that is in case of the hot weather concreting, where the concrete is set early due to the high temperature. Because due to the high temperature, the hydration reaction, the rate of hydration reaction increases, and due to increase in the rate of hydration, the cement will start to set early. So to avoid this, we can use the cement with the more amount of the dicalcium silicate. So to reduce the heat of hydration and increase the setting time of the cement. It is about dicalcium silicate. Next is tricalcium aluminate. The reaction of the C3A with water is very fast and it leads to the setting of the paste, that is immediate setting of the paste, and this process is termed as the flash set. To prevent this flash set, 2 to 3% gypsum is added at the time of grinding of cement. The hydrate C3A do not contribute to the strength of the concrete. So tricalcium aluminate is responsible for the early setting of the cement paste. So due to this, the cement will set immediately, which is known as the flash setting of the cement. So to avoid this flash setting of the cement, we can use, or during manufacturing of the cement, we add 2 to 3% gypsum so that there is a time available for the various concrete operations, so that mixing, transportation, placing, etc. So the compound C3A tricalcium aluminate is responsible for the early setting or immediate setting of the cement paste. Next compound is tetracalcium aluminiferrite. It hydrates rapidly. It does not contribute to the strength of the concrete. The hydrate of C4AF shows a comparatively higher resistance to the sulfate attack than the hydrate of C3A. So it does not contribute the strength of the cement, or it is not responsible for the setting time of the cement. It is having the resistance to the sulfate attack. So in case of manufacturing of the sulfate resisting cement, we can have the maximum amount of compound, that is C4AF, to make a cement more sulfate resisting. So these are the properties of the box compounds. Next is physical properties of the ordinary Portland cement. First is fineness of cement, that is grain size or particle size. Standard consistency, it is the amount of the water which required to make a particular cement paste. Initial and final setting time, that is the related to the setting of the cement. Compressive strength, that is the strength of the cement. And soundness, these are the properties of the cement. So to define or to understand these properties, we have to follow some tests in a lab. So these tests are, for fineness, we use the fineness test, that is to measure the size of the particle of the cement. The sieves are used, that is only one sieve, 90 micron sieve is required to check the fineness of the cement. Next one is consistency test, to determine percentage of required water, and for this we use the Vicat apparatus. The Vicat apparatus is shown in a image. Next is soundness test, to determine the ability of the cement to maintain the stable volume after setting, that is change in volume of cement is known as the soundness test. For this, Lee Chatelier apparatus is used. Next is setting time test, to determine initial and final setting time. For determining setting time, we require to use VCAT apparatus. That is, standard consistency, initial and final setting time are determined by using the single apparatus, that is VCAT apparatus. Next is compressive strength. To determine the strength of the cement, we use the cement with the sand and we check the compressive strength by using CTM, that is compressive testing machine. First is fineness test of a cement. The fineness test of cement is done to determine the particle size of the cement. The fineness of cement is determined by two methods: sieve method and air permeability method. We use the sieving method for determining fineness of the cement because it is the easy method to determine the fineness of the cement and require less time. So we go for the fineness test of the cement by using the sieve, that is determination of the fineness by sieving method. Importance of fineness of the cement. It can increases the final strength of the cement. Fineness can also affect the workability. Fineness test indirectly measure the surface area of the particle of the cement per unit mass. Fineness increases the strength development in the cement. It increases the rate of hydration. More is the fineness of the cement particles, more will be the rate of hydration. That is, fineness increases the rate of hydration of the cement, and rate of hydration of the cement affect on the strength of the cement. If rate of hydration increases, then there is an increase in rate of gaining the strength. So more fine cement will give early strength or more strength in early days. Also, more fineness leads to the more surface area, due to which it contact with the water and increase in the rate of hydration. Also, fineness affect on the workability, that is, fineness is responsible for the workability of the concrete. So the fine cement will give the more workable concrete. These are the some points which guide us regarding the importance of the fineness of cement. For determining fineness of cement, we require the apparatus. First is ISU 90 micron. Second is weight balance or weighing balance. Third is nylon brush or the pure Bristol. We use the brush to remove the some particle which are in a sieve. Next is sieve shaking machine. Optional, if it is available, then we can use the sieve shaking machine. Otherwise, we can done by the manually. Procedure: take 1 kg, that is 1000 gram of the cement for the test sample. and name it was W1. That is W1, that is the weight of the cement sample, 1000 gram. Rub the cement particle well with your hand so that no lumps are left. So we have to just rub the cement in the our fingers so that there is if any lumps, then they should be converted into the powder. Now pour the 1 kg cement contained in the sieve 90 micron and close it perfectly with the lid. That is, place the cement into the sieve 90 micron IS sieve and close it with the suitable cover, that is lid. Then sieving is done by manually or by use of the sieve shaker. If you have any sieve shaking machine, then put the sieve in the shaking machine and start the machine for 15 minutes. That is, the sieving can be done by manually or by use of the machine, that is sieve shaker. Next is, if we done the sieving or during the sieving of the cement, it is necessary to done the sieving in all direction for minimum 15 minutes. So either by manually or by machine we have to done the sieving minimum for 15 minutes in all direction. Next one, now just weight the retained amount of the cement on the sieve and note it as W2. So after sieving the cement through the sieve, the amount of the cement particle retained on a sieve is weighted and that weight is taken as the W2. Now you need to find the percentage of the weight of the cement retained on the 90 micron sieve. So the percentage of the cement retained on a sieve is equal to W2, that is weight of the cement particle retained on a sieve, and W1 the weight of the cement particle taken for a sample. For example, if after sieving the weight retained is the 5 gram, then and weight retained is 5 gram and the weight taken is 1000 gram, then the percentage of the fineness or the fineness of the cement is, for 5 gram retained particle, the percentage of the cement retained on the sieve or the is 0.5%. If the retained particles weight is 100 gram, then the fineness is 10% for sample 1 kg. So depending upon taken sample and weight retained, we can calculate the fineness of the cement. ज्यावेळी आपण फायनेस ऑफ द सिमेंट फाइंड आउट करतो त्यावेळी आपल्याला 90 मायक्रॉनचं सीव साईज लागते, म्हणजे चाळण लागते. ही टेस्ट सिंपल आहे. आपण 90 मायक्रॉनची सीव घेतो, त्याच्यामध्ये 100 ग्रॅम किंवा 1 किलो म्हणजे 1000 ग्रॅम सिमेंट आपण त्याच्यामध्ये घेतो आणि सिमेंट घेतल्यानंतर ते जे वेट आहे त्याला आपण W1 म्हणतो. फॉर एक्झाम्पल आता आपण 1000 ग्रॅम घेतलेला आहे, म्हणजे 1 किलो सिमेंट घेतला असेल तर W1 येणार आपला 1000 ग्रॅम. आणि ते जे सिमेंट आहे ते आपण 90 मायक्रॉन सीव मधून चाळून घेतो. ते चाळून घेतल्यानंतर त्याच्यामध्ये जे फाईन पार्टिकल असतात 90 मायक्रॉन पेक्षा कमी ते निघून जातात, पास होतात. 90 मायक्रॉन पेक्षा जास्त साईजचे ऍग्रिगेट वरती रिटेन राहतात. सॉरी पार्टिकल रिटेन राहतात आणि ते जे पार्टिकल असतात त्या पार्टिकलचं आपण सिमेंट पार्टिकलचं वेट घेतो त्याला म्हणतो आपण W2 म्हणजेच काय वेट ऑफ सिमेंट रिटेन्ड ऑन द सीव जे चाळणीमध्ये राहिलेले सिमेंटचे पार्टिकल आहेत त्याला आपण W2 म्हणतो मग W2 अपॉन W1 इंटू 100 केलं की आपल्याला फायनेस मिळतो इन टर्म्स ऑफ द percentage. After test, there are the values are given. That is according to the Indian standard or IS standard. The fineness are first according to the Indian standard, the amount of the cement retained on the 90 micron sieve shall never exceed 10% for OPC. That is the fineness of the cement should be less than 10% for ordinary Portland cement. According to the Indian standard, the amount of cement retained on the 90 micron sieve shall never exceed 5% for rapid hardening cement. That is for rapid hardening cement, the fineness limit is 5%. जर आपण सिमेंटची टेस्ट घेतली आणि त्याचं सीव अनालिसिस केलं तर ऑर्डिनरी पोर्टलँड सिमेंटसाठी पर्सेंटेज ऑफ फायनेस हा मॅक्झिमम 10% अलाव केला आहे आणि जर रॅपिड हार्डनिंग सिमेंट असेल तर त्यासाठी मॅक्झिमम 5% आपण फायनेस मॅक्झिमम त्यामध्ये अलाव केलेला आहे सो दिस इज अबाउट द फायनेस टेस्ट ऑफ द सिमेंट in next lecture we go for the remaining test sequentially that is the standard consistency initial setting time, final setting time, soundness, etc. So thank you for joining with us. Thank you very much.